Hey everyone, so this is the Remix Bay Area Meetup. Thank you everybody for coming. Today Tony's giving a talk. We do this every month, so check us out on Meetup if you want to come again. And Tony's going to talk about Passkeys.
Yep. Hi everyone. Great. So today's talk topic is going to be enhancing user authentication with Passkeys. So quickly, a little bit about myself. My name is Tony, and I would like to call myself a web dev tinker. And the reason for that is because I feel like I always tinker with way too many things. And I'm always like trying something new, and I feel like my mind's always like just like all over the place. But for today, I'm going to try and focus on specifically Passkeys and Remix. Honestly, mostly Passkeys, but a little bit of Remix as well. So to start off first, who here has heard of Passkeys before? 1, 2, 3, no? I think it's a good majority. And who here has actually used Passkeys to sign into an app before? All right.
Set up and fail.
Okay. Okay. So a little bit less. Okay. And then who here has implemented Passkeys in a web application before? They're almost the same actually. So yeah. So got one person. Yeah. Okay. All right. So hopefully you guys will learn a little bit today. All right, so during this talk, I'm going to try to answer a couple questions. So first off is, what are Passkeys? And then why should we even consider using Passkeys over passwords in the first place? And how do Passkeys work behind the scenes? And lastly, if you want to implement this into your web application, what resources are there out there? Okay, so let's begin. First off, what are Passkeys, right? So at a high level, Passkeys are an easier and more secure alternative to using passwords. So imagine instead of signing in with a password, instead use your fingerprint, face scan, or screen lock. So this should sound very familiar to how you unlock your phone. So imagine that same mechanism, except we are now using that same mechanism to sign into a web application. So just to make it a little bit more clear, because I myself, I'm a very visual person, so I'd rather see how things work in action rather than words. So I put together a little Remix app. So let me zoom in. So this is going to be the most Remix part of this talk, by the way.
Enjoy it, guys.
So let me make sure my server is running, just to make sure that it's actually a Remix app. All right. So this is a very, very simple bare bones Remix application. All it does is it has two routes, a login route and a register route. And you try to go to the homepage, it just redirects you to login. So right now, the first thing I'm going to do is register a new account. So I'm just going to put in my email, click register. So now I'm registered for an account, and I'm prompted to add a passkey. So I'm going to go ahead and do that. And as you see here, there's a little prompt that shows up. And this prompt basically asks where I want to create a passkey. And there's some options right here. So first there's iCloud keychain, Pixel 7a, which is the phone I have, and Chrome profile or another device. So this is basically just all the devices that Chrome has detected that has the ability to create a passkey and store a passkey for me. So these are basically your password managers. So just to make it a little bit more clear, if you guys have, for example, let me close this real quick and actually open up a new tab. Okay, so for example, if you have Chrome, if you navigate to your settings, so the URL for that is like Chrome settings passkeys, you can see a list of all the passkeys that are stored in your Chrome profile. So basically, it's a password manager. So let me go ahead and redo this since I left it. So let me just do another email, remix edit. Oh wait, because I need to register a passkey first. So I'm gonna register a passkey using my Chrome profile. And I'm going to use my thumbprint. And a passkey has successfully been registered. And over here, I just need to refresh this. And as you can see, a new passkey has been made and stored for this web app on localhost. So now if I log out, and then I log in again, so I'll just use my email, press sign in with passkey. I'll be prompted to use my fingerprint. And then I'm logged in again. So the cool thing here is this whole time, I never had to think of a password, right? And all I had to do was one motion using my fingerprint, and I was able to log into a web app. Okay, thank you. So before I go on to how everything actually works behind the scenes, I want to go over the reasons why we should even consider using passkeys over passwords in the first place. And the first reason is it's just a lot easier to use. As you saw, no passwords, right? So I'm sure everyone has had the issue where, you go to a website and you have to make a password, and then you have to have one uppercase, one lowercase, space, special character, but the special character has to be from a specific, group of characters, and you can never get it right. So all that goes away if you use passkeys. And additionally, if you don't have a password, then you don't have to remember your passwords either. Secondly, you have multi-factor authentication, but just with one action. So this part might be a little confusing because I know it took a little while for me to understand it. So it seems like you're only doing one thing. So it seems like there's only one factor of authentication going on right here, but it's actually multi-factor. So just a quick question. Does anyone here know what the possible factors of authentication could be with passwords and authentication? No? Yeah.
So,
Yeah, so basically, when we talk about factors, right, or logging in general, what we're really trying to do is we're trying to prove to a website that we are who we say we are. And usually to prove to a website that we are who we say we are, we have to prove that we know something, we have something, or we are something. So an example is whenever we sign in using a password, that is something we know, and only we know that, right? And then something we have would be like our phone or phone number. That is why after we sign in with a password, a second factor of authentication would be sending that text message to our phone with a code. And because we are the only one who should theoretically have our phone number, that code goes to us, and then we can prove that we have a second factor of authentication. And then another one that is used a lot is biometrics, right? So, or thumbprint, for example. So, so back with passkeys, the reason why it is still multi-factor authentication is because one, we're using our thumbprint, so that's one factor. And then the second thing is our device. So when I register a passkey, the passkey is actually stored on the device I registered it on. So therefore, the device is the second factor of authentication because it's something that we have. So with just one motion, we're able to sign in very securely with multi-factor authentication. Okay. And then besides being easy to use, passkeys are also way more secure than passwords in pretty much every single way. So they're immune to database breaches because, again, there's no passwords, right? So we're actually not storing any passwords on the server at all. And then secondly, passkeys can't be phished. So there's no way for a fake website to use our passkey because every passkey is domain specific. So if you try to use the passkey on another website, it just won't work. And I have a few slides coming up that will show a little bit more behind the scenes about how this works. So hopefully everything will make a little bit more sense after that. Okay, so how exactly do passkeys work? And to answer that question, I'm actually going to have to answer another question first, which is, what is public key cryptography? And this might sound a little scary, but honestly, I have this example that I think will make it super simple. So don't worry. So imagine you have three people, Bob, Jill, and Mike. And what Bob and Jill would like to do is send a message to Mike. So let's say they both send a message and Mike receives this message. But then there's a little problem. It turns out that Bob and Jill, they both forgot to sign their message. So when Mike gets a message, he doesn't know which message came from whom. So how do we solve this, right? And the answer, you might be thinking of it already. All we have to do is ask Bob and Jill, hey, why don't you just sign your message and then send it to send it to Mike. So you could do that. And we have two messages signed by Bob and signed by Jill. So now Mike knows which message is from whom. But there's another problem. It turns out that Bob is actually a really shady character. And he likes to sign his message as coming from Jill. So now when messages go to Mike, we have two messages seemingly from Jill, but Mike honestly doesn't know, right? These messages can be both from Jill. They could be both from Bob or one or the other. He has no way to know. So how do we solve this, right? And this is where public key cryptography comes in. So imagine that Bob and Jill, they both have a pair of keys. They both have a public key and a private key. And these keys are unique to each person. So I try to make it like different shapes right here to get the point across that the public key and the private key are a pair. And Bob's public key will only match with Bob's private key. And then the same thing with Jill is her public key will only match with her private key. So the way this will work now is we're going to have both Bob and Jill share their public keys with Mike. And then once Mike has these public keys, in the future, if Bob or Jill wants to send messages to Mike, what they will do is they will send the message, but they'll also sign their message using the signature of their private key. So now, when Mike gets the message, as long as the message matches with a public key, he will know which message came from which person. Okay? So now, how does all this relate with passkeys, right? So imagine instead of Bob and Jill, we have two users and we have our web application server, and we now want to sign in. So each user will have a pair of public and private keys. And this is what we call passkeys. So behind the scenes, passkeys are really just a pair of private and public keys. So in order to register with a server, what we need to do is we will have to have each user send their public key to the server. So once that's on the server, they're pretty much registered with the web application. And then when they want to authenticate and sign in, what actually happens is that the server will send a challenge to the user. So you can think of a challenge as basically just a string of characters, kind of like the message that was being sent back and forth. So the server will send this challenge, and then the users, using their their private key, they will sign that challenge and send it back to the server. Once on the server will check to make sure that, number one, the challenge is the same challenge that was issued. And then secondly, that the challenge has the same signature that matches the public key that is on the server. And if all that matches, then the user is verified and they can sign in to the application. All right, so that was kind of like the high level. And now I'm going to go a little bit in more detail, just to show how we would actually implement this in an actual application. So over on the right here, we have our server, and we have a users table where we store basically the user ID, email. And importantly, we are also storing a challenge that we will be using to sign them in. And then we have another credentials table where we store basically the public keys for the users. On the client side, we have our UI where we sign in. And then we have an authenticator that's also on the client side. So if you remember a while ago, I mentioned that the passkeys are stored in, could be stored either in my iCloud keychain, Google Password Manager, Windows Hello Password, 1Password. So this is basically your password manager. Okay, so in order for a user to sign in, the first thing that happens is that they will have to send their registration information to the server. So let's say an email, for example, and you can collect anything else you want, your name, last name, whatever other information. You send that registration information to the server. The server will add it to the users table, and at the same time, create a random challenge string. Once the string is created, it will send back the challenge string to the client. And then our JavaScript on the browser side will make a call to our authenticator. So this is when we are prompted to use our biometrics. And then the authenticator, assuming our biometrics check out, will create a set of private and public keys. So the private key will be stored in the authenticator app. And then the public key, along with the sign challenge, will be sent back to our browser JavaScript, which then forwards it back up to the server. And on the server, we have to verify this challenge. So what that really means is we're just comparing the challenge that we created with the challenge that was received. And if that checks out, we go ahead and store the public key on our server database. Then after that, we just had to do a little cleanup and get rid of the string right here in our users table. And this is to prevent replay attacks. And then we let the user know that, hey, you're now registered. So that's the flow that we need to do if we want to register a new user using Passkeys. So now, for the other process, which is how do you sign in now, right? So let's say now you have a user that is registered. So their information is in the users table. And we also have the public key stored as well. So the first thing that we need to do now is we need to say, hey, server, I would like to sign in. This is my information, for example, your email. When the server gets that information, it'll create a new random challenge string. And then that challenge string, along with the associated credential ID of the public key, is sent to the browser. Our JavaScript will again send it over to our authenticator. And we have to, again, prove that we are who we say we are. And if everything checks out, the authenticator will send back a signed challenge, which is then, again, forwarded to our server. On the server, the process will be very familiar right here. Again, we're going to have to verify the challenge. But at the same time, we also have to verify the signature of the signed challenge at the same time. And this is using our private key. Our public key. Okay, and then if everything checks out, the next thing we do is we have to clean up the challenge again from the users table. And then we send a reply back to the client to say that, hey, you're now logged in. And that's the process in which we would have to do if we want to implement this in an application. All right. So I know this was like a really high level overview of everything. So I wanted to add some more resources to look into. if you want to implement passkeys. And of course, the first thing that I'll always point everyone to is MDN. So the official documentation for the Web Authentication API is here. So the Web Authentication API is the API in which you build upon to implement passkeys. And then secondly, there's a really cool GitHub repository called Web Authn Awesomeless, which has a bunch of resources and a few libraries for making passkey implementation easier. And one of those libraries that I would suggest you look at if you want to implement this is the simple Web Authn TypeScript library. This is actually the library I used to make my demo that you saw earlier. And then, of course, since this is a Remix meetup, there is another repository called Remix Auth Web Authn. And it is basically a wrapper around the simple Web Authn library itself to implement passkeys specifically for a Remix application. So I highly suggest checking out that one if you have a Remix app. All right, so just some closing thoughts. Well, as you saw, passkeys are really awesome, but I do think there are a few things to consider before you implement them. So as awesome as passkeys are, there are definitely some cons. So one of the biggest cons, of course, is you have to use a device authenticator. So, all those password managers that I mentioned before. And because passkeys are a relatively new technology, not all users actually have a device that has a built-in authenticator yet. So if you use passkeys only for your web application, you might be alienating a lot of users out there. And then lastly, backups. So the keys cannot be recovered if, say, a user loses all of their devices. Hopefully that will never happen, but that is something to keep in mind. With a password, you can lose all your devices, but as long as you don't lose your memory, then at least you still have that, right? So at the end of the day, should we be using passkeys? And my answer is yes, but definitely provide backup methods just in case. And by this, I mean, in addition to passkeys, if you want to have a completely passwordless login system, the way to do it could be, in addition to passkey, to have users also give their email. So if they ever lose access to their account, they can get link for a one-time passcode sent to their email. And that way they can log back in and they can register a new passkey. Or if they don't have passkeys at all, they can just log in with their emails, and that'll be the only way they can log in. And here's just a link to a site that I think is pretty cool that shows a bunch of companies that have already used and implemented passkeys in production. It's a pretty long list, actually, as you can see. And there's some big companies that have implemented passkeys already. So Adobe, Amazon, Apple. So passkeys are definitely a production-ready technology, but definitely be aware of the cons before you go fully on board on them. Okay, so that's it. That's my talk. Thanks, everyone. Any questions on anything?
I just want to say your slides are really beautiful and super clear.
Oh, thank you, thank you. It was actually made using Excalibur. Yeah.
No way.
Yeah,
Wow.
yeah. Thank you. Yeah.
How much work was it to actually implement it in code? I feel like it's always one of those things I've heard that's like, oh, it's cool, but it's like a total pain to actually do the work of.
Honestly, I didn't think it was that difficult. It took me probably a full day to do it. And honestly, a lot of the time was me trying to make it work with Remix. So, and this is not, so, and this is not, it's actually because I was trying to use, are you guys familiar with the client actions? So, okay, so first off, right, so with Passkeys, right, if you do a form action with it, the thing that you have to do before the form action is you have to talk to the authenticator on your device, right? So you have to do a JavaScript call. So I was thinking what you could do is do a client action. But the problem is if you do a client action, the form data that you send to the server still cannot be changed.
Yeah.
So you cannot add in the data that you get back from the authenticator to your form action. So I couldn't figure out at least a good way to get client actions to work. And so I was basically trying to do it the most remixed way possible. And I think that made it a little complicated. Whereas I think if you were to just do a fetch request without doing any form actions, that might be an easier, cleaner approach. Yep. Yep.
So one thing that's important when you have passwords is a way to reset them with your email, right? Because everybody forgets their password. So like verifying the email is something that most services implement. In this flow right now, obviously you could probably add like verify your email, right? Like right after you come to the dashboard and then there's like a message, please verify your email, right? I'm just wondering if you also verified the email, could you use the email to ever like I lost all my passkeys. Can I?
Yeah.
Is it safe to use your email as a fallback to recover from losing all your passkeys, or do you think that's insecure?
So I'm not a security expert.
Yeah.
So
This is general.
so my answer might not be the most standard, but I think it is. And the reason for that is because there are, I would say, a good amount of companies out there. The first one that comes to mind is Slack. They allow you to sign in with just an email, right? So I don't see why that would be less secure in this case as well.
Right.
Yeah. What else? What else? You have nothing else that you can really ask for, right? Maybe the phone number if you have this problem. So, yeah. So
yeah.
Social security number.
Yeah.
Yeah.
Yeah, because there's that, and I know a lot of companies also use magic links. If you guys are familiar with that, it works pretty well. However, I did hear that with magic links, there's some concerns with it because some emails providers, if it's a link, they might block it as being spam. So that's something that you need to think about. That's why I hear that it's usually better to send things as plain text. So like instead of sending a link to sign in, send a passcode in which you have to type in instead. But the problem with that is that you are now exposed to phishing problems that could occur. Yep.
Can you have multiple passkeys for the same account?
Yes, you can. So you can have multiple passkeys and you can have it in multiple places and multiple devices. So the best thing to do if you have like an account that you want to make sure you always have access to is just make a bunch of passkeys like everywhere, on your laptop and then also on your phone, all the devices that you have. What's that?
So you definitely can't do that with passwords.
Yeah.
Different passwords.
Oh, I mean, oh yeah. I guess you can't do that. No. Yeah.
If you have it in your keychain
Uh-huh.
on iCloud, for instance, right? Or like in your Chrome profile, then it's probably also synced across
Yes.
all your devices.
Yeah,
also,
yeah.
Right by default.
Yeah, I'm not sure about the Chrome profile. For sure, iCloud keychain does that. And I'm pretty sure Windows Hello and there's one more, I forgot. But I think it's Google Password Manager will sync. But I'm not sure if the Chrome profile will sync.
If it's just a Chrome profile, then probably not. Yeah.
Yeah,
But like
yeah.
Google Password Manager.
Yep. Yeah.
So, what's the workflow for like having the same account and having different passkeys? Like if you have
Yeah.
phone.
Yeah. So I did implement it here, but basically what happens is when you go to a login screen and there's multiple passkeys registered, you can have a pop-up that shows all the because your authenticator will know what domain you're on. So it will populate every single passkey that's available on your device. So you can select from a drop-down which passkey to use.
Like for the initial creation.
Uh-huh.
Like if I'm logged in on, say, an Apple device,
Mhm.
passkey or whatever. And I know that I've got an Android device, I'm going to want to log in.
Uh-huh.
How do I create the passkey for the same user? Different
Yeah. So this will depend on your own implementation, but usually what I've seen done and what I would suggest right now as well is when you're logged in, just have a screen that lists all your passkeys and a button to add more passkeys.
Like
Yeah.
a settings page, right?
Yeah, like a settings page.
So the client tells the server first, like, this is the passkey that I'm going to be using. And the server has like a multiple, like, oh, it's this passkey that you want to be using, and sends a challenge that way, like.
The client would list the passkeys, right?
The client will list the passkeys.
Or I mean, like, so if you have like a multiple,
Uh-huh.
like, keys, or so like
Uh-huh.
multiple passkeys created for the same user.
Mhm.
So in that database, like in the table, how would you store, or how would you determine which of the public keys?
Good question. Yeah.
I think what I've seen done is that old, hey, verify on your other device that this is you on this new device.
Mhm.
Right, so you always need minimum one device. So your Android phone would send to your Mac. Is this really you?
Yeah, so the way, so that is, so the question, so the question is, what would happen if you have your passkey on one device, and let's say you have another device and you want to log into that one, but your passkey is over here, right?
Yes.
Yeah,
It
so
doesn't sync, because if it syncs,
Yeah.
then it's great.
yeah, so there's actually I've implemented this myself, but I saw a demo on it. It was pretty cool. So what happens is there's a Bluetooth connection that works. So let's say you have another device, let's say a public library computer, and you want to sign into your account there. But obviously you don't want to register a passkey on the public computer. So what you would do is when you sign in, when the prompt comes up, you can actually, if you have your phone on you and you have a registered passkey there, you can actually select use passkey from another device. There will be a Bluetooth connection that links the devices together, assuming they both have Bluetooth support. And then you can select your passkey on your phone. And then that your phone will send the sign challenge via Bluetooth back to your public computer. And this only works if the devices are within proximity of each other. And then you can sign in that way. So that way you don't have to, register a passkey on a device that you don't trust.
There's no app code needed for that, right? It's all the browser.
Yeah. So all this is like using the built-in, so Web Authentication API.
Would you mind sharing that existing projects that have done it on production again?
Oh, yeah.
It just struck me while I was like, while you were scrolling through here.
Mhm.
I mean, I'm actually kind of surprised to see, like, let's say more Apple, I know, basically, for places you need your history and really need your history, like let's say your bank or your
Mhm.
social or whatever, there, I'm not sure that, because you always need one device, right?
Mhm.
That is dangerous, but
Mhm.
for a lot of these sites where you don't really care, I mean, if you lose your Amazon history, it kind of sucks, but it's
Mhm.
not the end of the world, single
Yeah.
place, etc. It feels like it's a really good fit there,
Mhm.
especially since most people are using, I love travel 123.
Yep.
So I was just wondering if like what's like the most dangerous website on this actually switch to Passkeys?
Well,
most of the must.
So before we go down there, I want to say that I think most of these sites, I wouldn't say they've switched to it as much as they've added it on as an alternative.
Yeah.
So it's definitely, I don't know of any site that has gone 100% on passkeys.
Yeah, perfect.
Yeah, there's that. And so some sites have only used it for like another factor of authentication, like just another method that you can authenticate with. So, and I'm not sure, I don't think we can tell by this list which has actually gone 100% on
Yeah.
board with it. So, yeah.